from the following topics: magnetism, measurement 2, reflection at curved surfaces, magnetic effect of an electric current, waves, and fluid flow.
Magnetism. Subtopics: properties of magnets, magnetic and non-magnetic materials, basic law of magnetism, magnetic field patterns, the domain theory of magnetism, magnetization and demagnetization, applications of magnetism.
Introduction. Magnets are very important devices, either used on their own or as components of devices commonly used in everyday life. An example is the dynamo that lights the headlamp of a bicycle. In this topic, we are going to learn about some common properties of magnets and their applications. Properties of magnets. Magnets possess some common observation. When a magnet is brought into contact with iron filings, the filings get attached all around the magnet, but most of them cluster at the two ends of the magnet. This clustering is evidence that there is no stronger magnetic attraction at the ends. These ends are called magnetic poles. Directional property. In the following demonstration, a bar magnet is suspended freely in a horizontal position by means of a piece of string, disturbed and then allowed to settle. Play the animation and note the direction in which the magnet finally comes to lie.
To demonstrate the behavior of a bar magnet freely suspended in a horizontal position, click on the button to disturb one end of the suspended magnet so that it is set into rotations. Note the direction in which the magnet finally comes to lie. Observation. When a magnet is suspended freely in a horizontal position and given a slight displacement, it always rests pointing in a north-south direction. The pole pointing north is called a north-seeking pole, while that pointing south is called a south-seeking pole.
Magnetic and non-magnetic materials. To investigate magnetic and non-magnetic materials. The following activity is an investigation of magnetic and non-magnetic materials. Click on the button and observe the effect of bringing a bar magnet close to each of the following materials: matchstick, steel needle, silver, rubber, piece of chalk, copper, steel pin, piece of iron, nickel, and carbon rod.
Conclusion. It is observed that some materials get attracted to the magnet, but others are not. Materials which are attracted by a magnet are called magnetic materials, while those which are not attracted by a magnet are called non-magnetic materials. Magnetic materials include nickel, steel pin, steel needle, and iron. This summary is given in the following table. Magnetic materials include nickel, steel pin, iron, and steel needle.
Basic law of magnetism. What is the basic law of magnetism? What is the basic law of magnetism? The following video clip shows the behavior of a magnet A when a second magnet B is brought close to it. The procedure is repeated with an unmagnetized iron bar C in place of B. Note the situations in which attraction occurs and those in which repulsion takes place. Conclusion. From the observations, two north poles repel each other. Repulsion also occurs between two south poles, but north pole attracts south pole. These results can be summarized in a general statement known as the basic law of magnetism. The basic law of magnetism states that like poles repel each other while unlike poles attract each other. Magnetic field patterns. When a magnetic material is placed near a magnet, it is attracted. This shows that there is magnetic effect in the area around a magnet. This area where magnetic influence is felt is called a magnetic field. Magnetic field has a pattern which may be revealed by sprinkling iron filings around the magnet. Play the video clip to observe how this is done.
The ion fillings are observed to arrange themselves in a pattern which reveals the magnetic field patterns itself. This is represented in the figure below. The lines along which ion fillings align themselves reveal the magnetic field lines, also known as the magnetic lines of force. Properties of magnetic field lines. They originate from the north and end at the south. They are close together where the field is stronger, and they leave a surface at right angles.
Domain theory of magnetism. In magnetic materials, each individual atom behaves as a tiny atomic magnet or magnetic dipole. A group of dipoles with their magnetic axes aligned parallel to one another form a magnetic domain. In different domains of the same magnetic material, the dipoles point in different and random directions.
Magnetization and demagnetization. When a material is magnetized, the domains align in one direction. When all the domains are aligned in one direction, the material is said to be magnetically saturated.
Methods of magnetization. Magnetization process basically involves making the domains to be aligned in one direction as seen above. Suitable methods of magnetization are therefore those which enable us to achieve such alignment easily. Induction method. Activity 1.4 to demonstrate magnetic induction. Click on play button to observe the effect of magnetization by induction.
Discussion. The pins are observed to attract and hold each other, so they have also acquired some magnetism. The process by which the pins have acquired magnetism is called induction. Induction is a method whereby when a magnet is brought near a magnetic material, the latter acquires magnetism. What happens to the dipoles during the induction process? Click on the play button to observe the effect of magnetic dipoles of moving a magnet closer to a magnetic material, for example, iron bar. The magnetic dipoles in the iron bar are observed to align themselves in the direction of the magnet, and finally the iron bar moves towards the magnet. The alignment of the magnetic dipoles causes the iron bar to become magnetized. This is what happens during the induction process.
Electrical method. In this method, the material to be magnetized is placed in a solenoid connected to a direct current source. When a direct current, or DC, flows round a magnetic material, the material gets magnetized. Observe the behavior of a magnetic domains when the switch is closed and again when it is open. On closing the switch, current flows and magnetic dipoles are urged to align themselves in one direction, causing the iron bar to become magnetized and attract the steel needle. The end Y becomes a north pole and X a south pole. When the switch is opened, current stops flowing. The iron bar loses magnetism, so it falls off. Stroking method. Single stroke. In this method, the iron bar is stroked several times using a bar magnet as demonstrated in the following animation. Click on the button and take observations. Single stroke. During the process, the dipoles in the iron bar get more and more aligned with each successive stroking, so it gradually becomes magnetized. Finally, the attraction becomes strong enough to move the pin. Methods of demagnetization. Demagnetization process, being the opposite of magnetization, involves disrupting the alignment of magnetic dipoles. This can be achieved through any of the following methods: electrical method, heating, and hammering a magnet. Electrical method using AC current. Alternating current, or AC, is used instead of direct current, or DC. Alternating current keeps changing direction and hence disrupts the alignment of magnetic domains. Click on the button for animation to observe the effect of alternating current on the alignment of magnetic domains. Observation. With an alternating current in the solenoid, the alignment of dipoles or domains becomes disrupted and faces different directions. This leads to loss of magnetism.
Heating. What happens to the particles of a substance when it is heated? When a magnet is heated, the dipoles vibrate faster and faster and faster. This causes the alignment of dipoles to get destroyed, so the magnet loses its magnetism. Click on the play button to observe this effect. Hammering. What happens to particles in a solid as the solid is hammered? Click on the button to observe the effect of hammering the magnet. Hammering a magnet while its poles are facing in the east-west direction also disrupts the alignment of magnetic dipoles, and this fact can be applied in the demagnetization process. Applications of magnetism. Magnets have very important applications in real-life situations. These include removal of magnetic objects that may accidentally get into the body, sorting of magnetic materials from non-magnetic materials, lifting of containers at the seaport, being part of a loudspeaker, and navigation. Click on the button to observe some of these applications.